Ever had a paper cut or twisted your ankle? Maybe you stubbed your toe or scraped your knee as a kid? These small injuries are a part of life, and they all have something in common. That red, puffy, warm spot is inflammation, your body's built-in first aid kit, always ready to jump into action when you need it most. When you're hurt or invaded by germs, your body sends specialized cells and chemicals to clean up and repair. White blood cells rush to the scene, fighting off invaders and clearing away damaged cells, while chemical signals call for backup and help coordinate the healing process. This response is essential for healing. Without it, even a splinter could become dangerous. Inflammation is what keeps infections at bay and helps wounds close up, protecting us from harm every single day. But like any superpower, inflammation needs control. Too little, and we're vulnerable. Too much, and things can spiral out of control. Imagine a superhero who can't turn off their powers. Trouble, right? Instead of saving the day, they might accidentally cause chaos. That's what happens when inflammation doesn't stop. The body's defense system, meant to protect, starts to harm instead. When the off switch fails, the alarm keeps blaring. The body stays on high alert, and the healing process never finishes. This is chronic inflammation, a slow-burning fire inside your body. It simmers quietly, often unnoticed, but over time it can cause serious damage. Instead of healing, it starts damaging healthy tissues and organs. The very system designed to protect us turns against us, wearing down our bodies from the inside out. Chronic inflammation is the hidden culprit behind diseases like rheumatoid arthritis, heart disease, some cancers, and Alzheimer's. It's a silent force, quietly fueling many of the world's most serious health problems. It's a common thread linking many health problems. No matter your age or background, chronic inflammation can affect anyone, making it a universal concern. The challenge: how do we turn down the heat without shutting off our body's defenses? We need a way to balance protection and peace, to keep our inner fire in check. Scientists have been searching for the master controls, the tiny biological switches that govern inflammation. These switches could hold the key to stopping chronic inflammation without leaving us defenseless. If we could tell the body that's enough time to cool down, we could prevent so much damage. Imagine a future where we can fine-tune our immune response, healing without harm. Thanks to cutting-edge science and powerful microscopes, that day is closer than ever. Researchers are peering deeper into our cells, uncovering secrets that were invisible just a few years ago. We're on the verge of a monumental leap in understanding this process. Each discovery brings us closer to new treatments and a healthier future for everyone. Let's dive into how this breakthrough could change everything. Ready? Let's go. The journey to mastering inflammation starts now. Let's break it down and really understand what's happening inside your body when inflammation strikes. Imagine you get a bee sting and suddenly your arm swells up and turns red. That's not just a random reaction. It's your immune system's rapid response team springing into action, working to protect you from harm. Chemical signals, like tiny emergency flares, are released at the site of injury. These signals tell your blood vessels to widen, allowing more blood to flow in and bringing a surge of white blood cells to the scene. These white blood cells are the heroes of your immune system. Some of them gobble up invaders like bacteria or toxins, while others call for reinforcements and begin the process of repairing damaged tissue. The swelling, redness, and pain you feel? That's the battle in action, a visible sign that your body is fighting off a threat and telling you to protect the area while it heals. This process is called acute inflammation. It's temporary, targeted, and absolutely essential for healing. Without it, even minor injuries could become dangerous. Once the threat is neutralized, your body sends out the all-clear signal. The immune cells retreat, swelling goes down, and things return to normal, just like flipping a switch. The key to healthy inflammation is balance. Turn the alarm on when there's danger, deal with the threat, and then turn it off so your body can rest and recover. But problems start when the off switch fails and the immune system doesn't get the message to stand down. Chronic inflammation means your immune system stays on high alert, constantly sending out inflammatory cells, even when there's no real threat. This persistent, misguided attack can damage arteries, joints, and even the brain, slowly wearing down healthy tissues over time. It's a silent internal conflict that can last for years, often without obvious symptoms until significant damage has occurred. Chronic inflammation is now linked to major diseases like heart disease, arthritis, and even dementia, making it a hidden enemy within. That's why finding the source of inflammation and learning how to flip that off switch is absolutely crucial for long-term health. So, What exactly controls this powerful process? What determines whether inflammation helps or harms us? Let's take a closer look at the molecular switches and signaling pathways that regulate inflammation in your body. This is where the science gets truly fascinating. Unlocking the secrets of inflammation could change how we treat countless diseases. If inflammation in the body is controlled by switches, what do these switches actually look like? Are they simple levers, or something far more intricate and fascinating? In reality, they're tiny, complex protein machines, microscopic tools that orchestrate the body's response to threats. Among the most important of these is the ADAM17-IROM2 complex. Let's call it the AIR complex for short. This duo is at the heart of how inflammation is triggered and controlled. Imagine it as a pair of molecular scissors. ADAM17 is the sharp blade, snipping specific proteins like TNF-alpha, which is a key signal that tells the body to start an inflammatory response. When ADAM17 cuts TNF-alpha loose, it's like sounding an alarm, shouting "inflammation now" to the immune system, mobilizing cells to respond to danger or infection. But what tells these scissors when to cut and when to stay still? That's where IROM2 comes in. It acts as both the handle and the safety guard, keeping ADAM17 in check. IROM2 carefully controls when and where ADAM17 acts, making sure it only activates during real threats and not by accident. This precision prevents unnecessary inflammation. Without IROM2's regulation, ADAM17 would run wild, causing chaos by cutting proteins at the wrong time and place, leading to harmful, uncontrolled inflammation. Together, they form a tightly regulated system. IROM2 is the brain, making decisions, while ADAM17 is the brawn, carrying out the action. Scientists have long known this complex was crucial, but for years they couldn't see how its parts fit together or how it really worked at the smallest scale. It was like trying to fix a car engine with the hood welded shut, impossible to understand or repair without seeing inside. To design precise medicines that target this system, researchers needed to see its atomic structure, a detailed blueprint showing every part and connection. And now, for the first time, we finally have that blueprint. This breakthrough changes everything. Let's see how it opens new doors for science and medicine. In 2025, a team at the University of Cincinnati, led by Dr. Tom Seeger, achieved the impossible. They captured the first high-resolution image of the complete ADAM17 IROM2 complex. For the first time, we can see the master switch for inflammation. This is a landmark in biology and medicine. The AIR complex is unstable and hard to isolate, but Dr. Seeger's team developed new techniques to extract and stabilize it. Using revolutionary imaging, they revealed how IROM2 cradles and controls ADAM17 at the atomic level. It's not just a blurry picture. It's a detailed 3D map of every crucial atom. Now, we don't have to guess how this switch works. We can see it. Understanding the mechanics means we can fix it or build better versions. This discovery opens the door to smarter, safer drugs. The scientific community is buzzing with excitement. But how did they get this incredible image? Let's look at the technology behind the breakthrough. Enter cryo-EM. The secret weapon? Cryogenic electron microscopy, or cryo-EM. This Nobel Prize-winning technology lets us see molecules in 3D down to individual atoms. Scientists freeze the protein complex at ultra-low temperatures, preserving its natural shape. A powerful electron microscope takes thousands of images from every angle. Advanced software stitches these into a detailed 3D model, like a CT scan for a single molecule. This is how Dr. Seeger's team unlocked the secrets of the AIR complex. Now let's see what this map teaches us. This 3D map is a treasure for drug designers. Before, creating drugs to control ADAM17 was like picking a lock in the dark. Early drugs blocked too much, causing side effects. Now scientists can see the exact shape of the active site and how IROM2 interacts with ADAM17. They found unique pockets and grooves, features only on the AIR complex. This means drugs can be designed to target just this switch, not others. It's the difference between a sledgehammer and a precision tool. The structure also reveals how the complex is regulated by signals inside the cell. Researchers can now intervene at multiple points, fine-tuning inflammation without shutting it down. This complete picture empowers smarter, safer therapies. So what does this mean for medicine? We're on the cusp of a new era for treating inflammatory diseases. This discovery could lead to safer, more effective treatments for millions. For conditions like rheumatoid arthritis, new drugs could target inflammation with pinpoint accuracy, reducing side effects. In diseases like Crohn's or ulcerative colitis, drugs could calm inflammation in the gut without weakening the whole immune system. Some cancers hijack inflammation. Now we can block that pathway more precisely. Even brain diseases like Alzheimer's could benefit, as new drugs cross the blood-brain barrier and act only where needed. The key is specificity. Smart drugs, fewer side effects, better quality of life. This paves the way for personalized medicine, tailored to each patient's needs. It's a profound shift in how we treat chronic disease, but this is just the beginning. This isn't just another step, it's a fundamental shift. Dr. Seeger's team wasn't trying to cure a specific disease. They wanted to understand how this molecular machine works. Foundational research like this is the bedrock of all medical advances. The visualization of the AIR complex shows how technology and curiosity drive progress. Cryo-EM, chemistry, and biology came together to unlock a medical breakthrough. This work demystifies inflammation, turning it from a vague threat into an engineering challenge. Now we can see and understand the machines inside us. This empowers scientists, doctors, and patients alike. It's proof that even the toughest health problems can be broken down and solved. Science is a team sport, and this win belongs to all of us. So, what's next for this discovery? Let's look to the future. With this 3D map, scientists can use computer simulations to test millions of drug candidates, speeding up discovery. The best compounds will be tested in labs, then in animals, and finally in humans. This structure will also help answer new questions about inflammation and disease. Every discovery opens up more questions and possibilities. Technologies like Cryo-EM let us explore the inner universe of our cells. This isn't just about one protein, it's about hope for better healing and healthier lives. The future is brighter, and hopefully, a lot less inflamed. Thanks for joining us on this journey into the science of inflammation.